Yeah, hello everyone. Myself Maruti. Welcome you all to this math video session. In this video, I'm going to tell you regarding a trigonometrical sum. A little bit tricky. I challenge. You'll get it if you follow all the rules. Right. The question says like this: sin theta minus cos theta plus 1 whole divided by sin theta plus cos theta minus 1. He wants the answer to be 1 by secant theta minus tan theta. This is what he wants us. He's asking us to show that. Right. So while looking at the question, what are there in the question and what are there in the answer? This is what we are supposed to think always when we are dealing with the trigonometry. Okay. So what are the trig ratios present in the question? If you observe, the first thing what we are having is nothing but the sine. Okay. Sine is the first trigonometric ratio what is present in the question. And what is the other one? We are having something like cos. Okay. So we are having cos. Okay, now what are present in the answer? In the answer, we are having something like tan we have, okay, we have tan, okay, and we are having secant. These are the two things what we are having in the answer. In the question, we have sine and cos. In the answer, we have tan and secant. Right, now how to reach that? How to reach that? How can we get back to tan? Right, so I think if we are using quotient identity, tan is nothing but sine by cos, which is nothing but the quotient identity, right? By using the quotient identity, tan is nothing but sine by cos, means sine can be converted as tan with the help of quotient identity. What is that? Sine by cos. I repeat, sine can be converted as the answer tan by sine by cos quotient identity. Point 1. Now, how can the cos be converted into secant? If you check it out, secant is nothing but 1 by cos, right? Means secant, secant we can get from the question 1 by cos with the help of multiplicative identity. Multiplicative identity. You know the multiplicative identity, that is nothing but cos theta into secant theta is equal to 1. That's the multiplicative identity. This is what you are supposed to remember. In the question we have sine and cos. In the answer, we are having tan and secant. Alright. How to get it means, how the sine and tan are related means, sine by cos is nothing but tan. This is the identity. They are related from here to here, here to anywhere we can change. Sine by cos is nothing but tan. In the same way, 1 by cos is nothing but secant. Now, if you observe it carefully, right, in both the denominators we are having cos. That's the trick we have to. From here we have to reach this, right? Indirectly how they are related means they are related like this. But in both the denominators we are having cos. That's what the point what we have to observe here. So divided by cos, denominator cos. So in a practical way, what I am doing means take the question, right? Assume that that is the same itself as the question. Dividing, right? Numerator and denominator, right? By cos. That is the first step what we are doing. To get this answer, take this question and divide numerator and denominator by cos. That's the trick what we are going to play. I think you might have got it. Why I am dividing by cos? Why? Because in the question sine by cos, in the answer tan by. So tan is nothing but sine by cos. We need to get this, right? We are having, already we have sine, but if we divide that sine by cos, we will get a tan. Already we are having cos, right? So if you reciprocate it, we'll get it as cos. That's the relation we have. So what I am doing means the same question I am taking but dividing by cos numerator and denominator. That's what. So sin theta minus cos theta plus 1. That's the numerator. I am dividing the entire numerator by cos theta. Of course, right, this is the main line. Now again the denominator, this is the numerator and this is the denominator. The entire numerator is divided by cos. Entire denominator, what is the denominator there? Sin theta plus cos theta minus 1 is there. That entire stuff what I am dividing, I am dividing by, what's that? Cos. Here the entire numerator is divided by cos. This is the numerator is divided by cos, and this is the denominator. Entire denominator is divided by cos. Why did we do that? I have shown you why we are doing that. Now, okay, we are in the process of getting the answer now. We have to reach there. Now, do algebraic stuff, right? We made the arrangement. Now, from now onwards, you should start moving. So, sine, can I write this as sine theta by cos theta? Right, what did I do? I have split the cos to all the three terms in the numerator. First term, second term, third term. I am splitting this cos underneath. Again, the same sign minus cos theta by cos theta plus 1 by cos theta. Right, this is the main line. This is the main line. What I have drawn here. Okay, now the denominator, this cos I am splitting for all the three, that is sin theta by cos theta plus cos theta by cos theta minus 1 by cos theta. Hope you understood what I did. Divided both numerator and denominator by cos. Then I have split everyone. So after splitting, what we are getting? So if you check it out, cos and cos gets cancelled 1, cos and cos gets cancelled 1. You got it? After cancellation, what is there? Sin by cos. How to write sin by cos? Just now I said sin by cos can be written as tan, right? Tan theta minus cos by cos. If you cancel it, what we are getting? 1. Now 1 by cos can be written as secant theta. See, we are reaching there. See, we are having in terms of secant and tan. So how did you get the sin tan? Just now I said sin by cos is nothing but tan. I got it. Right. In the same way, 1 by cos is nothing but secant. I got it. Whole divided by. Now what is sin by cos? Is nothing but tan theta plus cos by cos cancel, we got 1 minus 1 by cos is nothing but the secant theta. Cool. So we got all the stuff. So this is the small logic thing. Divided by cos numerator and denominator. I have split it. Then I have cancelled with what is left over. Till here cool. But sum is not yet done. We are having 1 by secant minus tan. So we are having only 1 in the numerator, whereas we are having lot of stuff in the numerator. We need only 1. 1 means somewhere identity. Somewhere identity means I started thinking, how can I get a 1 in the numerator? This is the numerator we know. How can you get 1? And of course, sum is dealing with secants and tans. You have to remember. The only method is nothing but secant square theta minus tan square theta is equal to 1, which is nothing but square identity. Right, 2 with the help of this. This is the only thing which can bring 1 in the numerator. So our concept is only one thing. What is that? We need secant square theta minus tan square theta so that we can get 1. So I'm still thinking like that. So we need to work on. So what I did means to make it simple, the minus 1 which is present I kept to the corner. So which is nothing but tan theta plus secant theta, the minus 1 I pushed it to the corner. In the same way here, tan theta minus secant theta, right, minus secant theta, the plus 1 I have shifted to the side. Okay, cool. Now there is a beautiful logic here which you have to remember. What I am doing, the 1 which is present here, the 1 which is present there, I am playing with that. Why? Because I know second identity is secant square theta minus tan square theta is equal to 1. Okay, but can I write what is the meaning of identity? LHS is equal to RHS means in the place of secant square theta minus tan square theta I can keep 1. In the place of 1 I can keep secant square theta minus tan square theta. This is vice versa. In the place of this or this, anything. So you might be thinking, why I need to place? Why I need to place means we have to cancel few stuff, right? But because now what I am doing is just you will come to know. So the 1 present here, the remaining all I am writing like that. Tan theta plus secant theta. The minus is there. Now the 1 which is present there, I kept a big bracket there, right? Of course, the remaining all as it is. What is there? Tan theta plus minus secant theta plus 1. The remaining all it is there. The only the green dotted, the green one, The green one I am writing in terms of square identity 2. What is that? In the place of 1 I am writing it as secant square theta minus tan square theta. Hope you got it. In the place of 1, I kept a bracket. In that bracket, I have inserted secant square theta minus tan square theta. Now, so cool part, right? The same tan theta plus secant theta, it's already there. Now, if you check it out, is it looking like a square minus b square? Can I write it as a plus b into a minus b? You have to think on that. You know, this is a square minus b square. Right, a square minus b square is nothing but a plus b into a minus b. I like to use that formula. Here it became secant theta plus tan theta and secant theta minus tan theta. This is what the logic is. This is a square minus b square. I am writing in terms of a plus b into a minus b. A square minus b square is equal to a plus b into a minus b. Here a is nothing but secant theta and b is nothing but tan theta. You have to remember that. So now the remaining all as it is, right? Tan theta minus secant theta plus 1. Cool? Right? Hope you understood. In the place of 1, I kept secant square minus tan square. Why? Why? Because square identity 1 can be replaced with secant square theta minus tan square. Later on, it is looking like a square minus b square, which can be converted as a plus b into a minus b. Now, one more trick what you have to play. You are having a lot of tricks here. What I am doing means, in the next step, the tan plus secant, I like to keep it in the parentheses. See here, I am writing the same stuff. Tan theta plus secant theta minus the same, right? The secant theta plus tan theta into secant theta minus tan theta as usual, whole divided by tan theta minus secant theta plus 1, the same as it is. But you might be thinking, what did I do? I kept this as a single bracket, fine, and I am able to see the same thing here. Secant theta plus tan theta, secant theta plus tan theta, or secant theta plus tan theta, both are same, right? So what I am doing, secant theta plus tan theta, can I consider it as into 1? Yeah, secant theta plus tan theta into 1. Here also secant theta plus tan theta, of course, some into is already there. So what I am doing, secant theta plus tan theta, I am taking it as a common. I pulled it out. So this is what? Secant theta plus tan theta, I pulled it out. Right? If I pull it out, just now I said, if I remove tan theta plus tan theta, what is left over? 1. And what is the sign there? Minus. If I remove this one outside, what is left over? Secant theta minus tan theta is left over. And don't forget the denominator what it has. Tan theta minus secant theta plus 1. Cool? Now, still there is a lot of things. That's why this is an essay exam. Now, can I take the minus inside? If you check it out, secant theta plus tan theta is outside. Yes. Now, I am taking inside 1 minus secant theta, minus into minus, plus tan theta, whole divided by, what is there? Tan theta minus secant theta plus 1. Okay, now the actual logic starts. If you start working, can you compare the numerator and denominator here? See, 1 minus secant, 1 minus, of course, if you want to write in terms of perfect method, secant theta plus tan theta, I kept it out. I am arranging this part and this part in the same fashion so that I can cancel it out. So, tan minus secant plus 1, I am writing tan theta minus secant plus 1, okay, by tan theta minus secant plus 1. Now, I kept a bracket for both of them and I have cancelled the stuff. Okay, now what is left over? Secant theta plus tan theta by 1 is there. Why? Because it cancelled one time and one time. Okay, now what I am doing? Still, did you get the answer? No. What we got? Secant theta plus tan theta. But what is the answer? 1 by secant theta minus tan theta. Again, the trick goes, when we are having 1, just now I said, if we are having 1, use secant square theta minus tan square theta. Means secant theta plus tan theta is there in the numerator. In the place of 1, again I am replacing with secant square theta minus tan square theta. Right. Again, when it is in the form of secant square theta minus tan square theta, we are splitting in terms of a plus b into a minus b. That's what I am doing here. That's what I am doing. Secant theta plus tan theta whole divided by secant theta plus tan theta into secant theta minus tan theta. You got it? Now I kept in the bracket, right? I have cancelled this. 1 times and 1 times, and what's the answer left over? Answer left over is, so if you check it out, 1 by secant theta minus tan theta. So hope you understood. It's a tricky part, but you have to get it. Thank you. In this channel, I have been placing both math and science videos.